So number 5 from the worksheet, to calculate the pH of 10 millimolar arginine that has a net charge of minus 0.65. So anything, whenever you want to look at the net charge, you have to, its net charge will depend on the structure of the amino acid at certain pH. So for arginine, because it has 3 pKa, so it can be in 4 forms, like this diagram here. So how would you know which pKa go first? So pKa, the most lowest, will go first. So the first one is the 2.1 here is actually the pKa of the alpha carboxylic group. So the alpha carboxylic group will be the first group that protonate. And then the next one is the pKa of the alpha amino group here. So alpha amino group will be the second to lose the proton. And then the last one, last pKa over here, 12.48, is actually the pKa of this amino group at the side chains. So it would be the last one to lose its proton. And each step here, once you lose a proton, the charge will be less 1, right? So for example, here, when you lose the proton from carboxylic acid, you get the minor charge here. When you lose the proton from alpha amino group, you lose a charge here. And similarly, when you lose a proton from the side chains, you also lose a charge here. And next step is to look at the overall charge of each structure. So the first form here would be +2 charge, and this one would be +1 charge, and this one is neutral charge, and this one is -1 charge. So as you can see here that the net charge of -0.65 is actually in between these two forms over here. So now you have to use the Henderson-Hasselbalch equations to calculate the pH. But first, let's look at the net charge of -0.65. So because the first structure, this structure will give you a neutral charge. So it means that all of the -0.65 is coming from the last structure over here. So the last structure would refer back to B, and the neutral form here refer to A. So because A and B here would be required to plug into the Henderson-Hasselbalch equation, so you need to know which structure is the acid and which structure is the base. So if to calculate the charge of certain pH, so the net charge can be calculated by using this equation. So net charge will be equal to the charge of the structure times by equivalence or ratio. So in this case, So minus 0.65 equal to chart of the structure is minus 1, right? And then times by equivalence. So equivalence at this pH, equivalence of the last structure here would be equal 0.65. So if B ratio equal to 0.65, it means that your A ratio equal to 0.35 by 1 minus 0.65 here. So this value will be used to plug in to the Henderson-Hasselbalch equation to calculate the pH. So using the Henderson-Hasselbalch equation, the pKa in this case needs to be at this point, which is 12.48, and then plus log B is 0.65 divided by 0.35. And you can calculate the pH and you get 12.75 as the answer. Actually, at this step, you might need to consider the concentration of the arginine that you are given to, but since it's equivalent and it will multiplies by the same concentration, so it can be crossed out, and just using the ratio can calculate to the pH directly.